Namaskaram everyone, welcome back to the 7th episode of our master level design series, and in this episode I'm going to show you the procedural building algorithm which you can use to construct the structure of your buildings and primarily the exterior walls which you can control, and this algorithm will help you to optimize your levels with the help of level streaming, which we will cover in the future episodes. So in this particular one, I'll show you how you can first prepare the kit, that is the walls in the Blender, and then after that we will take them into Unreal Engine and then we will create the algorithm. And of course, once you understand everything, you can customize it with different textures or walls or size and everything. So without wasting any time, let's get started. Okay, so the first thing we need is to make a flat space for our building. So what I'll do, I'll go to my landscape mode and I'll select this ramp and I'll select this point and this point and keep the ramp width to 45,000 and side fall off to 0. Add the ramp and here we have a perfect plain landscape. Okay, so here we will draw the building. All right, so we are in the Blender now. Let's create the wall. Press A, X, delete everything. And now let's use Archimesh in the create Archimesh room. And here we will set the room height to 3.5 and the width 0.1. Okay, this is the thickness of the wall. We will remove this baseboard because we do not want that. And we will increase the length by 2. Okay, because we want a door and a window sometimes. So for that purposes, the minimum length should be 2. And please stick to these values for now. Once you are done with the algorithm, you can always customize the length, the width, and based on that, you can tweak those parameters in the algorithm as well. But for now, I want you to focus on these values only. Now go in the shading tab. I'll provide the link of the texture. You can download it. And it's concrete underscore 010. Press Ctrl Shift T, locate the folder that you have extracted and go for these texture maps. That is the displacement, color, roughness, and ambient map. So select it, you have your texture. Great. Now once we are done with this, you need to apply this modifier in this wall so that this thickness is applied. Now we go back to UV editing. So select everything by pressing A in the edit mode, U, Smart UV Project, Unwrap. Okay, so there you have all your boxes. Now scroll on the top, select the material mode to see the texture. Now what I want is, I want to have only 4 blocks. So I'll select the face mode by pressing 3 and I'll select both of them. Or you can just select the first one first. Let's fix this one and go for 5-1 so that you exactly see the front. Now I want you to drag it all the way here just so that this edge is barely visible. Okay, so we will go 4 in columns and 6 in rows. Okay, so I'll select the first two, G, Y, and we will go for almost 6. So just make sure the edge is barely visible. Okay, all right, so I can see the edge barely. Then I'll select this again, 5-1. Let's go for the top, that is the bottom, G, Y or X, and almost there. Now we will go for the left and right. So G, X, make sure it's barely visible, not too much, not too less, barely. Okay, and in GX for the left two vertices, barely visible. All right, good. Now if you duplicate this wall by Shift D, press X to move it in X direction and press right click. First enable this magnet, make sure increment is set to true. You can see there is another room duplicate, GX, and just touch it. Okay, so you can see it is visible. So I'll select this again and just barely touching. So first I'll go for this one. Okay, and then I'll do the left side. And you can delete this and duplicate it again in the X direction, and there you have it. Now it's looking perfectly fine. Okay, now you cannot spot the difference. If the edge was not there, then these two blocks will look big. Also, one thing, I do not want these cracks on my walls, so I'll go to shading and I'll remove this displacement pin from the material. Once you do that, you will not see anything that is connected with the displacement map. Go back to UV editing, and now we need to map it exactly in the back. So I'll select this wall, select the front face, select the back face, and now I'll just overlap this second face to this first one. So let's grab it and make sure you do not grab this one. Just place it barely. Okay, it has to match exactly and precisely. If you do not know Blender much, then I recommend you follow the first two episodes so that you get a hands-on practice, and then you can always do more on your end. Okay, so now we have everything on track. Now what do we do is select this top one and make sure these three lines, and let's see, this is the wall. So somewhere here we will get this box. So let's get it here almost, and in between, then G Y actually almost here. Okay, now we need to grab this one. Make sure there are only three edges in the picture. Do not try to compress or resize it. Instead, tackle both the ends separately, okay? This does make sense up to some extent, right? Cool. Now you can do the same thing in the bottom. You can select this and this. We will take this one, and first thing is to rotate it by 90 degrees and overlap. Okay, I think this is good enough. Cool. Anyway, this will be on top and this will be in the bottom, so it will not be visible much, but this one will be for sure. So I'll grab it again, and this time, first of all, let's take it here, then G, Y, and make sure you have 6 or how much? 1, 2, 3, 4, 5 lines. So 1, 2, 3, 4, 5. Do not try to compare this one because this is a duplicated mesh and it is not unwrapping the UVs for this one. So don't go for that. Just focus on this one. So we want 5 lines. 1, 2, 3, 4. Okay, there are more. Okay, this is good enough. Now let's, so we go like this. So select entire UV face, GY, and just shift it up. And this will match precisely. All right, so we have this one ready. Let's delete this mesh and let's apply the same UV here. So I'll first select this face and this face, and then I'll grab it, place it exactly here. Okay, great. This looks perfect. The wall is ready. Now you can duplicate this and you will see no difference. Okay, so let's delete this one, and now this is our wall. Let's save this file, shooting range structure kit. Okay, save it. Once you are done, you can rename this to wall, or let's just say plain wall. Okay, now we go back to modeling, enable the texture mode. Now we need to make the corner walls. So for this, I'll duplicate this X and I'll drag it here. Make sure the grid snap is on. So this is one. So let's duplicate it again, and in Y direction, RZ 90 degrees, and select both of these walls by pressing Shift, then GX. Make sure this edge is on center. Once you have this, let's drag it in the Y direction, and there you have it. Cool. So first thing, now we need to connect these walls. So what I'll do, I'll press Shift H and I'll hide everything. Then I'll go in the edit mode, press 3, select this face and select this shear. Once you select the shear, select this one and make sure this turns like this. Now release it and then change this value to 1. Once you will do that, you will see it is twisted. Great. This is done. Select back and object mode. Press Alt H to bring everything back. Now let's go for this one. Now I will select this, press Shift H, select this face in edit mode, shear, and then let's see, this is the correct pin. So I'll go for -1. Okay. Once you do that, you can go back to object mode, Alt H to bring everything back, and there we have our wall. Cool. So select this, press Alt G, select this, press Alt G. And let's move this by going 7 in the top orthographic, GX, GY. Okay, now it is joined. Cool. So it is perfectly matching. Now we need to change their origin. So I'll select this one first, press tab, select this vertex, Shift S cursor to selected. This will move the cursor here. Now we want this origin to be here. So I'll go in the object mode, right click, set origin to 3D cursor, and the origin is here now. Now do the same thing for this one. Go in edit mode, select this vertex, Shift S, cursor to selected, go object mode, right click, set origin to 3D cursor. Okay, now both the meshes have origin right here. Now what you can do is select these two, R, Z, and you will be able to rotate both of them. This is what we will do as well. We will not rotate single wall, we will rotate both the meshes. Do not join, because if you join, then the scaling will be impacted. So do not join, and make sure this is how exactly you export it. So these two are ready. Let's rename them. This one is cornered wall left, and let's copy this and rename this one to corner wall right. I pressed F2 to rename. Okay. All right. So we have wall and the cornered wall. And now let's create one more wall for our doors. So I'll duplicate this X and move it here. I'll rename this to door wall. Okay. And now I will press N to bring the create Archimesh and select outside, and in the Archimesh add a door. Once you do that, you will see it got spawned over there. What I will do, I'll select this plus thing GX and move it here. Okay, and let's select these three and hide them. Okay, let's focus on this. I'll select this door frame. I'll set its width to 1.35 and the height to 2.5. This is the ideal situation for our SWAT soldier to work out. I recommend do not change these values for now. Then we are good here. Okay, we need to make a hole in this wall of this size so that this space is empty so that door can open and close. Select this wall, go for auto holes. Once you do that, you can select this door RZ and you can see it is opening. Now this door frame, let it be, and what I want is select this door wall, press Alt G, it will move everything to center. Okay. Now what you will do, you will select this door. Remember, once you are all set, you have to make sure all the origins are placed at world center. Otherwise, you will have origin shifting issue, which we do not want. Because if I press Alt H, you will see this wall is not at origin. So what I'll do, I'll select this wall, Alt G, and this is also right here. So this is where the origin would be. Okay. Now I want you to save this. Okay. Now select this door wall, uncollapse it. Select the entire hierarchy, Shift H to hide. Now what do we want is, we want this door to be detached from this mechanism, because this is going to be a separate mesh for our door actor, which is going to perform the rotation, locks and everything. So what we will do, we will select this door inside which there is a handle back and front. Remember, once you are done, then only do it, and do not save after this point. Go for Alt P, clear and keep transformation. This will detach this door mesh from this door wall so that it becomes an individual entity. You can rotate and select this door, all the three meshes inside it, holding shift. Select this object and remove these locks. Once you do that, you can press Alt G and these things will be in center. But we do not want that, so let's do Control Z. What do we want is, if you carefully observe, this door has its origin here, but we want origin here. So I'll go edit mode, select the vertex mode by pressing 1, select this vertex, Shift S, cursor to selected, then go in object mode, right click on this door, set origin to 3D cursor. Okay. Now, if you press Alt G by selecting this door, this will go in center. This is how you will export this door. So this is our door. This is our door wall. Once you are all set, do not save. Export everything. But before that, let's unhide everything here. And we don't need to apply any texture. We will pick it from the Unreal Engine. So press A to select everything and make sure everything is active. All the eye icons should be on. Except this door group, baseboard, hole. Okay. Select A, file, export, FBX, and let's create a new folder. In this, I'll say shooting range structure kit. Selected objects, only meshes, and animation is not there. No leaf bones. In the geometry, apply the face smoothing because Unreal takes this one, and export. Alright, so that's it for our kit. Let's go back to Unreal. Now you can either save this file as an incremental, or you can close this and you will be back to your old progress. Why I'm saying not to save this is because right now you have detached this door and now you no longer will be able to do the modifications in this door. So that's the reason I asked you not to save. Okay, and now here, let's go in the level prototyping. In the meshes, I'll go for new folder, shooting range kit, open it up, import, locate your new folder and import this shooting range kit. Reset the selected pipeline in case you have something configured. After you import, you will have all your meshes. Great, we are set. Now let's select these 4 walls, all the static meshes, and press F to go near. And you can see, let me reduce the camera speed to 0.33 or maybe let's say 1. Great, so you have your meshes. So now you can select these 2 corner walls and move it here. And select this plain wall, move it aside. Okay, so these are the 3 meshes. Let's start building through them. Now see, one way is that what you do is select these walls, okay, then duplicate them and always make sure grid snap is on so that you move the pieces precisely without randomization. Now let's say you made these 2 walls, you select these, Control D to duplicate, and now you can rotate them. Now make sure you select both of these walls. One way to avoid selecting these 2 is you group them by here. If you group them, now whenever you will try to select this wall, both the walls will be selected because they are grouped. Now if you press E, you will move both of them. Okay. And if you want to ungroup, you can always right click and groups, ungroup, and you will be able to select both of them. But whenever you will rotate, make sure you rotate both the walls. So this is one of the ways to create the buildings, that is you duplicate these meshes and you keep making your architecture. In that case, you will end up creating a lot of meshes in the outliner and it will be very difficult for you to manage, keep track and select the right instances. So we do not want to follow this approach. Instead, we will create an algorithm that can do this job for us. So we are going to remove everything from here and this frame as well. Let's save all. In the architecture, we created these 3 architectures. Let's create one more folder that says buildings. Okay, open this up, right click, blueprint class, actor, call it B underscore building exterior. Okay, hit enter. You can name whatever you want. Now what do we do is we drag this right here. Now what we will do, we will take the inputs and based on that, we will spawn the static meshes here. Now to avoid spawning multiple static meshes here, you can use something called as instance static mesh. Now this instance static mesh takes the mesh, let's say this is our wall, so let's rename it wall and use a prefix ISM. That means instance static mesh. You will take wall, or let's call it plain wall, sm underscore plain wall, and change this to static mesh. Select it, compile it, and now you can select your wall here, that is your plain wall. Compile it. Now you can use this actor for different walls of different textures, So what I'll do, I'll expose this on spawn and make the instance editable, and I will keep this as a default. If I go to level 1, you will not see anything. Now there is something called as construction script. Construction script runs when this class or the actor is placed in the world. Right now you haven't played, you have just loaded this class into the memory. Right at that moment this will run. So that means whatever things you will execute here, they will be executed right here at this moment without playing the game. Event begin play works when you start the game, when this actor is spawned. Let's observe this. What I'll do, I'll get this instance static mesh and I'll call something called as add instance. So this instance static mesh component will store all the instances of wall with their transform. That means their location, rotation, and scale, and it will spawn them automatically. So it will not fill your outliner. If I connect this, compile, and let's split this, compile, and in the instance static mesh wall, you need to set this static mesh. Now, one way is that you take this static mesh plain wall and you get this instance set static mesh and you provide whatever wall you are trying to spawn. Compile, you will see it spawned a wall for you. See, there is no static mesh of this wall. You can spawn as many as you want. Like for example, if I duplicate this, place it here, and let's say 600, compile, you see there are 2 walls now. It has the location and rotation, and you see there is no addition in the outliner. It's going inside the building exterior. Great, now let's start building the algorithm. I'll delete this. Okay, let me turn off my camera because we will be accessing this space quite a lot. Great, so we can set the plain wall here, but the walls can change. I mean, you can have different textures. So we need to expose this variable so that you can edit it from the level. Expose instance editable, compile, and this will set the static mesh. Now we will have the corner walls as well. But before going into this, I would like to create a structure. I'll right click, search for structure. Please ignore this new file. I made some mistakes, so I had to re-record. Struct underscore building config. Okay, open it up. Save all. The first thing that we want to know is how many walls you want per side. Okay, so if building has 4 sides where each side involves 10 walls, then you have 40 walls. 4 sides, 10 walls per side. So it's like a square made from 40 walls. So this building config represents the side. So first thing we want to know is how many walls you want for this particular side. So save it, go back to building exterior, create a new variable, call this sides, and then go for struct building config. Once you do that, this is one side, but we want an array. So we'll go for an array, compile. Now we need to expose this and make the instance editable from the level. Go there and you will see the sides is exposed. Click on plus. Let's say I want 4 walls. So the type should be integer. Save, go back. Let's hit compile here. Go back and change this wall to 4. Now it should render 4 walls. So what I'll do, I'll create a sequence node. I'll comment this by initialization. And let's break this. This is my second bin. Now, how do we know this position? So first we are here at 0, 0, 0, right? This wall was spawned at 0, 0. So we will add the size of this wall in x direction and we will reach here, right? Let's say it is of 4 units. So 0 plus 4 becomes 4. So 4, 0, 0 will be here. So this is the position of the next wall, right? So we need to calculate the size of this wall. Now you can also make this wall bigger. So first let's handle the scale part. I'll call it scale. Change this to float and I'll do in the initialization and I'll change this to single actually. And I'll create a local variable, call it wall size. Okay. Now we will get this wall size. Now we will get this static mesh. We will get its bounding box. Okay. Whatever wall you have provided us, we will get the bounding box. This will give us the max and min, which is this is the minimum, this is the maximum point. We will get these two, subtract them, and then we will get the size. So I'll subtract minimum from maximum. Now this is at 1, 1, 1. But let's say if you want to scale it twice, then we have to multiply it by that number, which you are going to input here. So we will expose this, make it editable, and then we will multiply this number that you are going to give us. And this will be our wall size. So first here, second here, and we will split this. We only want in x direction, so we'll plug it here. Okay, so this is your wall size. Now this is okay, and we need a wall vector. So I'll create a new local variable. We'll say wall scale vector. Change this type to vector. Get it here. Now initially scale is set to 1, 1, 1. Which we'll do here. But if you have higher scale, then we will multiply this wall scale vector, which is initially 1, 1, 1. So multiply and connect this here. So you have the wall size, you have the wall scale vector. And now let's say you want to have a square building. So this is the first side of that building. The side is this, and let's set the scale value to 1 by default. And we will iterate over the sides. So for each loop, we will get the sides. We will promote it to a local variable. We will call it side config. Okay, so this is the current side config that iterator is on. We will get this side config and we want to know how many walls do we have to spawn. So I'll break this. I'll get this side config. I'll split up. And I will go for loop. And this should be here. Connect this here. And now we know the scale from here. So let's get the scale. Let's keep the rotation 0. And now we need to know the previous location of the wall. So let's say this starts from 0, 0. This will go into the second index. We need to know what was the position and then we will add the size so that we get here. Okay. So for this, we need to create a variable that stores the location of the last wall. So last wall location. Every time we spawn a wall, we update the last location. And that location is nothing but the last wall location, and then we add the size. So we need to know the size. So for this is the wall size, but we need to know the wall size vector. So we need to know the vector value. This is just width. So what we will do, we'll create one more and we'll call it wall size vector. Okay, we will get this wall size vector. We will get this wall size. And we want in which direction do you want? Because remember, if you rotate this wall like this, then we have to add walls in this direction. However, if it is like this, then we have to add the walls in this direction or maybe in that one, but it will be along X, right? So we need to know what is the direction in which we have to add the walls. So for this, we will create another variable that will keep track of direction. So we'll call this direction vector. By default, the direction vector will be of -1, 0. Okay. And in case someone manipulates the default value in any way, we can always put it back -1, 0 here. Okay. Now we will access this direction vector and we'll say this is the wall size, but in which direction? That value is in this variable. So I will multiply and this will give me the wall size vector. This is similar to the forward vector. I hope if you haven't seen the interaction system episode, I highly recommend because we have used the forward vector over there a lot. So I highly recommend if you want to understand this mechanics of why forward vector is important. So this direction vector will act like a forward vector for us, in which direction we have to add the walls. So whatever the last wall location, we will just add in that direction. That is the wall size vector, which is constructed. Okay. And we will keep it here. And this is the new location. So if I compile, go back, you see it added in that direction, negative. Okay. First it was here, then here, then here, then here. All right. So this is how you add the walls. Now see, there are two situations. One is either you go in left or you go in right, because you cannot go straight. Because if you wanted to go straight, you could have just increased the count, right? But now you want to turn. So turn can only happen either in the left or in the right. So that means we have to spawn the left and right cornered walls. So for this, I'll duplicate this ISM wall 2 times. I'll call this cornered wall left, and let's copy this name, paste it here, and wall underscore R. So this will keep track of right cornered walls. This will keep track of left cornered wall, and this will keep track of plain walls. Great. Now we need to know the meshes because you can change your textures. So we have to make that flexible and dynamic. I'll create one more variable. I'll call it sm underscore cornered wall underscore L. So static mesh of cornered wall left. I'll call this static mesh type. Then I'll create another variable, copy the previous name, just change the value to R. Great. Compile, and the default value would be in the level prototyping meshes kit cornered wall left, place it here, cornered wall right, place it here. You can override it from the level editor. So we will expose it. Cool. So now we need to know if you want to spawn a corner, and the corner will only come once all the walls are placed. This is the first side, and now we want to give a corner. So it is not necessary you want to give a corner. Sometimes you might just want to leave it. So we need to create another variable. We will say B has corner, which means this side has a corner. We will say boolean. If it is, then spawn it. So we'll go for a branch node. Let's bring it here. Go for a sequence node. We'll use a lot of sequence node. Put a branch node, put a condition, and then we will say if it has a corner, then we will spawn the corners. Go for a sequence node again. Copy this entire thing. Paste it here. Remove this ISM wall. Get this wall left. Get this wall right. And duplicate this. This is our wall right. Okay, so both the walls will be spawned. Make sure scale vector is used so that scale is applied. Let's see in the demo. If I go to level 1 and if I mark has corner, you will see nothing happen. So we will get the last wall location. We'll connect this here, duplicate this, connect it here, and we need to set those walls in this ISM. So just like we did for the wall, we have to set these values in these static meshes. So let's do that. I'll create another sequence node here. Grab it on top, break this pane, connect this one, and I'll duplicate this 2 times. Okay. Now let's replace. First we will get the static mesh left, right, and remove this one. Okay, I accidentally deleted that. Then we will get the left wall and the right wall. Please make sure this is wall left and this is wall right. Okay, so we have saved the left and right walls static mesh in the ISM. Now you can see the corner has appeared. Okay, what if I want to turn this way? Then the corner has to be rotated this side. So we need to know what is the yaw of this corner, right? So we'll go again, create a new variable, corner yaw. We'll change this to float, save, and now this will give us the yaw. So what do we do is get the local variables side config here, and let's break it. Use the corner yaw, and to use it properly, let's make a transform because location, scale and rotation will be same for both of them. We will break these, we'll recombine. Okay, and this is the last wall location. Rotation, we need to get the yaw. Wall scale vector will be this. Transform goes like this. Okay, let's get rid of these two. And actually, maybe we don't need the sequence node. Okay, so I've beautified this a bit. Compile, go in the level 1 again. You see your walls. Rotate this corner yaw to 90. You will see it is rotated. Do not keep any other value apart from 0, 90, minus 90 and 180. These are the ideal sharp angles that you must follow. Okay, otherwise it will not work out. This algorithm currently is for sharp angles. If you have other variations, then I would recommend going for the spline approach, which we are not covering right now. Cool. Now, if you go in left or you go in right, so this is not a practical angle. So either it has to be 0 or it has to be 90. Let's start from 0. This looks okay, but if you go close to your wall, you will see it is overlapping. You will see this flickering. Please keep track of this flickering because sometimes you miss it, and this is the biggest problem when creating the procedural building. So make sure your walls are not overlapping. So in such cases where your wall is overlapping, we want to push this wall further. The reason is we constructed 4 walls and this corner is superimposing on that last wall. So we want to push it ahead. Okay. So if this kind of situation appears, then we need to know whether shall we push this corner. So I'll say push corner. If this is true, then we will push it one step ahead. Okay, so whatever the last wall location was, we will just add this wall scale vector again so that it assumes that there was a wall added and it will increment. So what I'm going to do, this is a branch. If the branch has the corner, then I'll go for a sequence node. First thing I'll do is check whether this push corner is true or not, because if it is true, then I have to increment the last wall location. So I'll take this last wall location and I'll push it one step ahead. So whatever the last wall location was, just add the wall size vector again. Now you will add the corner. So compile, and this is supposed to be done only if you have selected the push corner. So I'll take this further and I'll check whether this is true or not. So duplicate this and select this one, hide unconnected pins, and we'll say push corner. So if you have selected push corner, then it will not flicker. Right now it is. I'll select the push corner and it pushes the corner. But now if I change to this direction, let's say by 90, and you see it is going off, which we do not want. So in this case, we have to add a very small amount of delta so that it gets pushed back. The reason this is happening is because of shearing. Remember in the Blender, we sheared these two faces so that we can give a joint look. So that is the reason why it is happening. So we will push it. This situation is not happening in the 0 case, right? So we need to know whether this is happening or not. And if it is, then we will push it. So for this, we will by default take a small delta. If it is fine, then it will be 0. But if you want to make correction, then you can provide us the delta. So this is a flexibility. So I'll say corner delta. It should be of type vector so that you can provide us the value in any direction. So we have the last wall location here. So now anyway, I have to update this last wall location. Doesn't matter if you want to push the corner or not, because I want to add this delta. So instead of using a branch node, we will use the select node. So I'll go for select vector. So if you want to push corner, then we will take this result. But if you do not want to push vector, then we will carry with the last wall location because it is valid. And then we would like to add the delta that you have given us. If you haven't, then it will be 0. There will be no impact. And we will set this here. And we will add a comment. We will say push corner. And this will be C add corner walls. Okay, let's mark comments so that we can find our stuff later. Now if I compile and go back, now I can provide the delta. So you have to figure out the delta. It's not in the X direction, it is in the Y. Now, if you have followed me in the Blender path, then this value will work out. If you are not following the Blender path, then you have to figure this out. Now this is a scale 1. If you have a higher scale, then the value can vary. So first decide whether you want to follow this or not. Because if you are following the 1 scale, then it will go -5 in the X because it was overlapping, and then -5 in Y to get it perfectly aligned. But if you scale this up to 2, then the values has to be increased. Okay, 2 ways. One is you can directly scale the actors. Another way is you scale the wall. So I'll go for 2 scale, little bigger walls. And now I have to change this to -10 and -10. Okay, now the corner is overlapping. And let's say if you change your mind and you want to switch to that direction, then you don't need this. So you set it to 0, 0 and everything is fine. All right, I'll undo. So now once the corner has been built, it is going to change the direction vector. It was going in X, now it will be going in Y. So every time you arrive on a new side, next side, then you will swap the direction vector. Why I'm saying this is because if you add a new side and take the count to 5, you see it's still adding in that direction because we haven't told that the corner has appeared, we have to switch the side. So first thing is we switch the axis, then we switch the direction. Right now it is on X, we change into Y, then we will decide whether we go in left or right. So there are 2 switches happening. First is your axis, second is your direction. So we'll go to build exterior, and every time you arrive at new side, you will swap the direction vector. So we will drag everything to the bottom. We will get this side config. We'll go for a sequence node. First thing we are going to do is switch the axis. So I'll get my direction vector. No matter in what direction you are, if you are in X, it will become Y. If you are in Y, it will become X. So for swapping, we will create a function. So I'll create swap vector X, Y. And what I'll do, I'll add a pin and I'll call this swap, p swap. And what was the vector that you were trying to swap? So vector, change it to vector type, then go for a return node, add another vector, call it result. So if you want to swap, then we will break the vector. We will split this, X goes in Y, Y goes in X. But if you do not want to swap, then we will return the vector as it is. So connect it. Please make connections properly. I've seen many viewers sometimes forget these connections, so please be careful. Now, since this is not modifying or interacting with any external entity, we can mark this function as pure. And now we will call that function here swap vector xy, and we'll say true because we want to swap, and then we will set it to direction vector. So we have successfully changed the axes. Now let's connect this here. We have to use this direction vector in this wall size. So this is the wall size. Remember, wall size in which direction represents how much shift should happen. So we have to take this new direction vector and we have to recalculate this wall size vector. So what we will do, we will break this from here and we will bring this in the bottom, because this is going to happen every time you have a new side. So we say this is your wall size vector. Now if you compile and go, you will see the stuff is changed. It's okay. Let's remove everything and add again. I want to have 4 walls. They are appearing like this. This is not correct. We have to rotate this. Now I want you to remember one more thing. Anytime the side is finished, you have to take a turn. So every time you take a turn, you have to add 90 degrees into it so that the wall rotates. Makes sense, right? So if I am going straight, let's fix this first. I'll create a new variable in the local variables. I'll call this wall yaw. Okay. And I'll use this wall yaw in this transform rotation. Split this, connect it in the yaw. Now this wall yaw will be updated right here. And I'll set it to by default 90 degrees. Let's do it first. Our wall is straight. Okay. Now, once I get here, I want to make a corner, right? So if I do corner, okay, it's happening in this direction. And I rotate it by 90 degrees and I will push it because it is overlapping. Now I want to add walls in this direction on this axis. So this is confirmed that this orientation has to be rotated by 90 degrees. Now if it is positive or negative, that will be determined by your decision whether you want to add walls in this side or in this side. So what I will do, I have to add 90 every time. So I'll add 90 degrees in wall yaw every time a new side appears because I have to rotate the wall anyways. But now in which direction should I rotate? That is a question. If I compile and if I add a new side and if I set it to 4, you can see it switched the axis. That is correct. And it is adding the correct rotation. That is also correct, but it is not adding in the correct side. So the direction has to be told by you that in which direction do we continue. Axis is calculated by the algo. Now you have to tell in which direction. So we'll go in building config and we'll create another variable. Call this b turn right. By default it is left and we want to turn it to right. So if you want to turn it to right, then I have to do minus 90. So for this, I will get this side config. I'll break it. Go for turn right. I'll select float. I will multiply by 90. Now if you have selected turn right, then I have to multiply it by -1. So I'll do -1. If not, then it is +1. And that is what we will connect here. Okay. Now if I compile, go in the level 1, and if I select the turn right in this side, it does nothing because this is for the yaw. And the second thing is the direction. Remember, the direction vector tells us on which axis and on which side. The turn right tells us this side. So we will go to exterior. So what I'll do, I'll also multiply the direction vector with this value so that we change the direction, not the axis. Axis is changed. Now it's time to change the direction. So compile and you can see the axis is changed and the direction is changed. You can always turn back. You can turn right and change the corner to -90. It should be 180 actually. Okay, you are back. Okay, so I have undone to this particular setting. Now you see this corner was okay, but now this wall is going off delta. Again, the same reason. So now it's time to add delta for the wall, not for the corner this time, because this is spawning at the wrong place. So we'll go in config again and we'll say wall delta and we'll go for vector. Save it. So now let's make it nice. I'll select everything, press C, call this set direction of walls. This is what you are doing here. I hope this makes sense. First we change the axis, which is inevitable, and then we will switch the direction if you select the right. Okay, this is sorted. Now we need to add the delta. So that delta has to be added here, right? This is our plain wall. So we will get this last location and we will add the delta that is required. So let's get the delta, and what I will do, I'll get this, break it, recombine, and I'll break. We'll say hash corner and wall count, and then this is the wall delta which is connected here. And let's hide all the unconnected pins, and we will connect this location here, compile, go back, and now in the second side we want to add a small delta that is 10 in the Y because it was overlapping. Like I told you, that you should keep track of this flickering. So first fix this by wall delta 10, then in Y wall delta 10. Okay, now you can see the wall is perfect. Now we need to add a corner after this wall, so hash corner, and now we will change this to 180. Now you see it is overlapping. So whenever you spawn an actor, you have to push it one step ahead. So we'll push it, but this is not sufficient. We have to push it one more time. This is because of the kind of direction and yaw we are taking. So once my side is completed, add size vector into last location again, and do not connect it to completed pin because it has to be done anyway. If you attach it to completed pin, then let's say you do not want any walls, then this will not run. So this will not fire. So we will create another pin in the sequence node, and let's drag them down, and I will duplicate this and connect it here. It might look a bit complex, but trust me, this is the most simplified version I can come up with and I can explain. So let's reorder the pins correctly. This should be done after this. Okay, and we have to add the delta. So get the delta. Okay, so this logic is about adding the walls. Add walls of side. Okay, I hope this makes sense now. If I compile, go back, you can see everything is fine now. So you has a corner, you push the corner, and then you add the correction, this time minus 20. Minus 10 will not work out, okay? And keep track of the flickering. There should be no flickering. Cool. So this is done, and now we no longer need to push the corner in this case. So let's remove that. Okay, everything is fine, no flickering so far. Now we will add walls in the third side. I'll say 5 walls. And now I have to make a correction. So let's say 10 minus 10, and now I can see it is flickering, so I have to add 10 in Y as well. Okay, then we add a corner after this wall. So add a corner, and then you rotate it to minus 90 degrees. You push the corner, and then you add a correction in the corner this time. That is 10, 20. And we are good, no flickering. You can add one more, add 5 walls, and this time it should be turned right. So turn right, and you see now this wall is overlapping. Why is it happening? Because you said 5 walls, but one wall is already completed by this cornered wall. So we have to make a parameter that allows you to push the walls further because one wall is completed by this corner. So we'll go back, we'll say b push wall, save, change this to boolean. Actually, let's change this to push side. That will be much better name. So I have to push the side. So the push should happen before the walls are added. So what I will do, I'll go for another sequence pin, disconnect this, connect it here, and let's bring everything down. We'll go for a branch node, duplicate this. We want to know if we have to push the side. Hide all unconnected pins. If you have to push, then get the last wall location and just add the wall size vector and the last location. You can just copy this entire addition. Connect it here. And now we will put this under comments and we'll call this push side. All right, so we have to select everything again, pull this down, make some space, and we got this. Okay, now if I compile and go back, I can select push side and it pushes. Now I need to fix the flickering and the offset issue. So wall delta -10, +10, and we are here. Okay. Now we have to connect this wall. So first of all, I'll decrease the wall count to 4. I'll say it has a corner. It added a corner perfectly. Make sure there is no flickering. And we need to add one more wall here. So just go in the first index, go for 5 walls, and you have connected successfully. Here is your square shape. Save all. Now there is one check, that is what if you do not enter any walls. If it is 0, then still it is adding one wall. So we will go in the building exterior, and this time I'll add a branch node here. So the push side and add walls should not happen if you are not having any walls, right? So what I'll do, I'll actually create a sequence node on this one. So let's connect the sequence node here. The first will go for this branch, then go for a sequence node again. Then you will follow the loop and the wall side. Okay. But in any case, the last wall location will happen. So I'll move this away. Let's duplicate these two. Add the wall delta here. Hide the unselected pins. You will bring this. And let's also go for has corner from this one. Okay, nice and easy. So what we are saying, if we have the walls, then only go for these two logics. So I will duplicate this. I'll check if the wall count is greater than 0, then only proceed. If it is not, then you should not proceed. And we should go -1 index. So subtract -1, because let's say you gave 2 walls, then it should go up to 1 index, 0, 1. So 2 iterations and 2 walls. Okay, I think we can expose wall delta here and we can connect this here. And this can stay here. Great. So this thing is also sorted. Things are going crazy. Trust me, if I do not do this style, then it will get way more complex. And working in blueprints is very, very difficult. Okay, so this is done. I will, I think, add another pin here instead of connecting this. I'll get this entire logic. So compile, and now everything is up to mark. You have your square. Great. Okay, let's file and save all, and let's make a complex structure than this. I will add another exterior. I'll go for first side, and let's say it has 5 walls, and I'll set the scale of this entire thing is to 2. And let's bring it here. Okay, I'm here. I'll add a rotation, and let's also move this aside. Now in this sector, I'll add a corner. So now I just want you to observe how you can play with these parameters. I know you already know after doing all this stuff, but still, you do has corner in case you are jumping directly on this point. I'll go 90 degrees. Make sure no flickering. Okay. Once you have pushed the corner, you are good. Let's go for another one. I'll this time no walls, directly corner, and not in the left, in the right side. So go for right. Rotate this to 90 degrees. No. 180 degrees. No. Minus 90. Yes. And I have to push it because it is overlapping. So this is the case when you want to attach corner to corner. That's the reason I told you that what if you just want corner, no walls. There is a flickering, so fix it. This is because of the corner, that is this one. So 10, I think. No, 20. Yeah, the flickering is gone. Okay. Now I want to add another side of wall that will continue here. Let's say I want 3 walls, not in the right direction, in the left. So in the left. No flickering. We are good. Now I want to add a corner. So added a corner, rotate it 90 degrees. Now we have to push. So push. There is offset issue. Add the corner delta. Minus 10. No, minus 20. No flickering. Okay. Then we add another side to carry on with the walls. I'll say 4 walls in the right direction. And I have to push these walls. So push the side. Then I have to fix the offset issue. So wall delta this time because these are the walls. So it is in the Y direction. So minus 10. Make sure there is no flickering. There is a flickering. So we have to fix in X. I'll add 10. Okay. We are good. Now we will add another corner. In this side, we will rotate it 180 degrees. Make sure no flickering. Neither on top, neither on horizontal. And now we will add another side. This time, let's say I want to keep 3 walls. I have to push. So push the sides. Fix the error. 10. There's a flickering. 10. We are good. Once we have this, let's say I want to add a corner again. And the corner here is minus 90. Make sure no flickering. Now I want to, and let's add a corner again. So add a corner, no walls. 180 degrees. I want to add this on that side. So turn right, and this should be 90. And I have to push this corner. So push this corner. There's a flickering, fix the error. We'll go 10, no, minus 10. There's still a flickering, increase the count to minus 20. Okay, we are good. No flickering on the walls. Now we'll add another side, which goes like, let's say 6 walls in the left direction. So turn, no flickering. Okay, and now I'll add a corner. So add a corner, 90 degrees, no, minus 90 degrees, yes. Push the corner, fix the delta issue, that is for the corner. So in the corner, it should be 20. No flickering. I will add another side. It goes 5, turn, push it because it is overlapping. So push the side. It is coming forward. So minus 10, then 10. We are good. Now we can leave it empty, or we want a corner. So we have to reduce the count so that we can have a corner. And now we need a wall again. So select this first side. all the way 0 and increase it by 6. There you have a complex structure, not just a square. Okay, see, no flickering, no gaps, everything is procedural, there are no meshes, everything is inside the exterior. So that's it for this video, guys. I hope you enjoyed it. Do let me know in the comments if you have any doubts, questions, suggestions, or feedback. And if you like my algorithm and you want to have the second release of it, in which we can add doors, windows, and we can even remove walls if we want. So if you like this setting and you are okay with it, then let me know in the comments. I'll release that in this next episode. And if you think this is too complex for you and you have some other alternatives that are much better, then it's completely all right. I will carry on with the AI and NPC chapter, because now we have the landscape, we have a building. So we will now introduce the AI characters a bit, and then we will come back to the military base. So see you in the Master Unreal series, and do join the Discord server. And if you want to skip the Blender part, you can always download the FBX of these walls from the Discord. And if you like my work and you want to support me, the Patreon page link is in the description. Please have a chat with me on Discord before buying any membership. So take care. I'll see you in the next episode. Bye.